I'm hoping that this visual will help support your understanding of first principles. In this case, we're looking at y equals 3 on x, and you can see the graph here, and we can see the other half is obviously it's reciprocal down on the third quadrant. But what we're looking at is trying to find the derivative at this f point, which is 1, 3 on the graph. But before that we do that, I want to look at the general case. And we can use the piece of technology to actually find it for us. And that's exactly the gradient that we want. And we can get it to measure that slope, which we've done for many years, way down through the school. And the gradient there is -3. And we sort of know that because the funny thing with first principles is that once you start learning your rules, we know that we can do it so much quicker. So we know that that's equal to 3x to the minus 1. So dy by dx, the gradient, is going to equal -3x, take 1 away from the power, which is equal to -3 on x squared. And at this point, when x is 1, then we're going to get the fact that the gradient when x is 1 is -3 over 1, which is -3, which we can see is exactly the same. But that's not really what I wanted to show you. I wanted to show you how it visually works with the graph and how we then can use first principles from the original. So I'm just going to pause the video and come back to you. So first principles is like as if we are back in year 9 and 10 and all we know to work out the gradient is y2 minus y1 over x2 minus x1. Or we used to use word sayings like rise over run. So here we got the point that we were talking about before. And we could use the point and call it actually 1, 3. But in this case, I'm just going to call it x. And really it's not y. Well, it is y, but really what is y? Y is 3 on x. So I'm going to call that point x and 3 on x. So therefore, we're then using this scenario need another point. So if this point here is y1, we need another point somewhere else on the curve over here, and we're going to call that y2. And do we know the coordinates of that? Well, yes, in this case we do. It would be 13 for the x, and the y value would be 3 on 13. But let's again talk more general. So you can see here that I've got a purple line between B and A, and call that distance h. So therefore we could say that if this point is x and this distance is h, then this x value is x plus h. And the y value, well, the y value is the same as before, except that x is replaced by x plus h. And that is where we get that first step of the first principles equation from. So I'm just going to pause that and make this screen a bit clearer. That will get that the gradient of any point on this curve is this equation, y2. So let's just come up with, make sure we understand where y2 is. So this is x2, y2, and this is x1, y1, and we've used this formula here. So there is our y2 minus our y1 over our x2 minus our x1. And what are we meaning here? And don't forget, this must be written every single time on the questions. We're saying the limit as h turns to 0. So what we're really saying is that this distance between the point that we actually want and a random point somewhere on further is actually going to shrink and it's going to turn towards 0. So watch what happens to this red line as we reduce it down. As we reduce this distance h, and we can see h getting smaller and smaller, perhaps what I can do is I actually will get that distance for you a second, so bear with me. See that this distance is 12. Why is it 12 when this value for x is 13? Well, 13 minus 1 is 12. But as I said, as we grab this point, we can see that that h distance gets less and less and less. And as it becomes less, what do you notice about the red line? Well, the red line becomes exactly the same as the blue line. And don't forget, the blue line is the tangent, and the red line is the chord or the average rate of change between 2 points, and we can see that it actually becomes the same as h turns towards 0. And that's what first principles is really all about. It's reducing that h value down so that it becomes the tangent. So what I'd like you to do now is pause the video and see if you can solve this equation, and you know that you're trying to get the answer of minus 3x to minus 2, because we know that from doing it the quick method on differentiation. So have a go. So here is the final solution, and you can see that I have it in the form like I rearranged one up here. But just to go through a couple of things, there we have the equation that I had before. This is very common when you have minus and you've got to expand this bracket out. So very common that students will miss this negative just in here. And secondly, that if you've got a fraction on a sort of fraction or divided again, that these two bits can come together. We can talk more about what that is, or you can ask to become this as the denominator. Keep going with the limit as h turns towards 0. Don't forget about that. The h's here then cancel out to leave us with this. And once the h's cancel out, then we can say that as h does turn to 0, what happens? Well, this becomes 0, and therefore we're left with x squared on the bottom, and that's where it comes from. So hopefully you found that useful. Hopefully you like the visual of seeing that as h turns towards 0, that it becomes the instantaneous rate of change. And all it is just practice and good luck. Thanks for watching.